Damn, this is like the perfect alternative.
Yeah. Easier to play too.
Yeah.
Especially if you're drinking.
All right, shut up! Monday, 4:30 p.m. to 6:30 p.m.
Skeet shooting? There is not skeet shooting.
It's on the list.
You can't shoot on
So-
campus.
So we have the Grace Cookout / Trump rally. / Donald Trump rally. Bring your gas masks.
Seriously, do I need to bring mine?
No. All right, so Grace Cookout, it's like the end of the year dealio. This is spelled correctly, Regent's Atrium. So this is on Monday, 4:30 p.m. to 6:30 p.m. I strongly encourage all of you to attend. Several of you are in my evening class that night, so this is perfect timing. And
Goes through our evening class.
well, no, we'll leave before. It's by the time it's 6 o'clock, it's going to be winding down. Okay, but you get free food before this. I assume there's going to be burgers and brats.
So are you playing volleyball?
Yeah, oh yeah.
Oh,
So we're going to do sand
Are you wearing
volleyball.
the bikini.
Well, I do Speedo, but
No, you gotta wear the bikini.
I
You
do
gotta
Speedo.
control
I
them.
do Speedo and Crocs, and then I do a backwards Donald Trump supporter hat. Do we get hats? Do you have hats?
Maga, maga, maga.
What do you mean you can get that? I mean, if you're like a big supporter, shouldn't you like be able to provide me with a hat if I want to join Team Trump? Oh, so you won't give me a hat?
No, you need to call him. You're friends with him.
Yeah, but what?
You want a hat
No, I want a free hat.
to support him.
No, like now. Like, well,
Give
soon.
this man a hat.
Soon. Like, I want a hat like soon. I won't have to work that hard for a Trump hat. Yeah, so in any case, I strongly encourage you to come to this. Free food and drink, sand volleyball, raffle prizes, skeet shooting, going away party. I think they're going to have a dunk tank. I think you volunteered for that, right? Yeah.
If they need someone, then why not?
What's this?
It's not.
You have-
You said that.
Did you have to explain it to him?
No, he
Wait.
said. Well, he said it's a you can't swim joke. I don't know if that was what you were going for.
Oh, but that's true. Can you?
Can I swim?
That fell backwards, so your joke failed. Mine was better, just like dunking people. Well, those people. For the record, the recording has started. 3 minutes in. So, yeah, I don't think there's a dunk tank, but there's definitely skeet shooting. So I encourage you all to come to that. Senior seminar presentations start next week, Tuesday and Thursday, 2:35 p.m. to 6:45 p.m. in Pharmacy 08. That's the big lecture hall on the first floor of Pharmacy. I'm going to try to bring a cooler with a bunch of sodas in it and stuff like that.
Beer?
But, well, of course.
Okay.
Yeah, of course. We'll have a cash bar.
Okay.
Unless you're presenting that day, and then for the duration of your presentation,
You just
it's
gotta
a
slam shots of tequila.
it's an open bar. You're starting to stretch the presentation out a little bit.
Who wants to do shots?
Okay, now that I've shown my project,
See, there's a
everyone
there's a minimum time limit for each presentation. So for every minute you come up short, it's 5 shots to be taken immediately.
Well, won't Tim rob the bar?
Wait, so if you're getting punished, do you still have to pay for it?
No, it's free for you during your presentation. All
All
right, shut up. Shut up. All right, so
Die all alone.
yeah, he's in Korea right now. So
So is he
he's,
Skyping in or what?
no, he's going to be back by then. He's just not going to be back for these.
Broadcast that to everyone.
We'll record it. All right. So, extra credit opportunity. If you, and this does not apply to those of you who are in senior seminar, because you have to attend I'm going to say a majority of the presentations.
Can I say that I'm pretty sure last year it did apply to them?
Well, I don't care. This is a new year. What does that even mean? Last year?
Less time for
What,
you to work on
like,
your
what does
project.
last year even have to do with like?
This year? It's the same.
It's the same offer. So yeah. So if you're in senior seminar, you should attempt to attend as many of these as reasonably possible. I understand that there's a lot of presentations, and some of you have work schedules and stuff like that. But having said that, I should see most of the senior seminar faces at many of the presentations. Yeah.
Don't the presentations go later than that on Tuesday the 10th?
Tuesday the 10th. I think they might slightly. I think they might go to like 5:35 or something like that. But for promoting this out to the campus, I didn't want to make it look like it was beyond the scheduled time period. Yeah. So in any case, the extra credit opportunity for this class is if you attend at least 2 presentations. I encourage you to attend more. I'll give you a free quiz. But if you're in senior seminar, you don't get that advantage. So
By 2, do you mean 2 presentations or
2 presentations. So that's an hour commitment. So each presentation with questions is 30 minutes. I'd encourage you to look at the sheet. So I think I've sent it out already, but I think haven't I put it? I've put it up on Slack, and so you guys have a list of the presentations and the descriptions of them. So I'd encourage you to come to as many of them as you can, specifically ones you're interested in, but attend as many as you can. Hopefully several of you could relate to this, is that when you're a senior and you've worked hard all semester doing something and you sit up there and you present in front of a room of 3 people, it's kind of demoralizing. So we want to get as many students coming to this thing as possible, so they're interested. Yeah.
If I could present in front of 3 people, that would make me very happy.
Why?
Because I hate presenting.
What, are you scared of groups? You get nervous?
Talking in front of groups, yes.
He
And I
went
know
to
you
himself.
See, that's where
I know.
See, that's why
So
the
you
alcohol-
prefer 3 people?
That's why
Yeah.
the alcohol
In
will
one
help
cup?
you.
It's more personal if it's only 3 people.
Where is Ryan Guy presenting?
Except that I don't want people to see.
I don't even know.
Okay.
Wherever we can find a room at that point in time.
You should tell us where he's presenting though, because I want everyone to go to that.
I'm guessing it'll be in here, unless there's a class scheduled. So I'm thinking it'll be in here. Shut up! All right. So free quiz if you show up to a minimum of 2. You don't get extra credit if you come to more than 2, but you'll be in my good graces. That might come into consideration when I am curving final exam grades and that kind of stuff. So, you know.
We're grading our actual senior seminar.
Well, how does that help you?
Because if he comes to all of them, that would help.
Oh, I get what you're saying. If you're in senior seminar and you attend all of them, or a majority of them, yeah, that's a true statement. That would certainly be in your best interest if you showed that you were dedicated to not just your own presentation, but also supporting your classmates. That would certainly bode well on your grade on a borderline situation. So, good point. All right, questions about senior seminar or the Grace cookout thing? I also want to encourage everybody to go to the Grace thing. That's been a pretty big hit this year. We've tried to start a ACM chapter on campus for even a traditional ACM, not female centric.
Sorority for girls' home.
Well, I mean, it's actually a bigger deal. I mean, historically, there's traditional ACM chapters that are male and female, but in computer science, you traditionally have mostly male. Well, we've tried to start that on campus before, and it really hasn't done very well. Well, Grace this year has actually done quite well, being female-centric, which is, I mean, I think that's fairly impressive to the people who have supported and also the people who are running it. So I'd encourage all of you to support that effort and also come and get free food. So they're bribing you to do that. So I'd encourage you to come and support that. All right. Any other comments about any of that crap? You're good? All right. So let's get back to our Delio, I believe we had a scanf that was avoiding string tokenizer at the end of class last time, right? Oy. Oy. All right, now currently, so remind me from the homework assignments, currently our homework chat server is accepting, probably in a somewhat ghetto way, is accepting private messages that get requested based on the file descriptor, the socket, the file descriptor of the connected client, and you probably have your server broadcasting those, right? So just whenever somebody connects, maybe the server just does a dump of all the current connected clients, showing you the IDs or something like that, so you know what your options are for who you can send messages to. And then your message, I know last time a couple of you said that, you know, you just had a very specifically formatted message or something for sending it to somebody. So now we have a way of maybe accepting specific tell commands and that kind of stuff. And then we also talked about signals last time, where what was an example of something we might use a signal for in our chat server. So there was a disconnect between the server side and the client side.
When a new user connects.
Yeah, so when a new user connects to the server, the client might be interested in knowing that so that they can broadcast to their connected clients that, you know, so-and-so has just connected, or, you know, at least a new user has entered the room, since we still have this as a fairly anonymous situation where people are connecting. Kind of makes some sense? So our homework over the weekend is going to be to bring your private messaging up to stuff with our scanf, and we'll do this string compare here today. So integrate that into yours, and then also broadcast, well, not broadcast, send a message specifically to your connected client if you're a child when a new user connects. So that's going to involve signals. We're going to talk about both of those things today. All right, so let's get this string compare thing working here initially, because right now, I believe we were printing out, let me get our, we were printing out command, and that looked legit, right? Let us command like this. Hey, nice to see you, Chastity. You missed some stuff. It was good. The extra chunky only. Doesn't a company make super chunky?
Sure they do.
That's just peanuts.
Is it? I mean, so you have smooth, then you have extra, then you have what, chunky, then you have extra chunky, and then you have.
Creamy, not smooth.
Is that creamy?
think
I bet you there's some. I bet you like Meyer brand.
Yeah.
I bet you Meyer brand has like smooth.
Yeah.
I bet you that might still be a thing. So you have creamy, chunky, extra chunky, and then super chunky. Is that like a?
I think it's extra chunky, not super chunky.
No, there's some brand that makes it, but I don't know if that's like an upgrade or if that's their equivalent.
Just check Slack.
I think they just go up with levels, and eventually you just get like ultra chunky, and it's just a jar.
Just check Slack. Just look at Slack.
Ultra chunky.
I solved the words. Just check Slack.
I don't want to do that on.
Oh no, it's just a link to Amazon. Swear to God, link to
It
Amazon.
is.
Well,
I can vouch.
link to Amazon is
It's a link to Amazon for Skippy peanut butter.
$16.
It's a 40-ounce container.
Skippy peanut butter, extra crunchy.
And super chunk.
Yeah, see, I told you.
no spirit formula for no oily mess.
Someone watching this video is like, why did they start looking at Amazon peanut butter?
All right, shut up again. Let's keep cooking, or I'm not going to be able to give you enough information for your homework assignment, and it's going to be harder. I've already given the assignment, so it's happening. What's up? All right, so let's go ahead and we'll read in from the user. We'll do tell as our command. Let's just print out and make sure that guy. C dot slash a dot out. Tell blah blah. All right, so there's our proof that it's tell, but our string compare, man. Let's see. Oh, that guy returns an int. It should return a 0 if they're the same. I think that's the issue. So if string compare tell command blah blah is equal to 0, that means they are the same. Then we'll say send private message. Otherwise, send to all. So let's go and sending private message. Okay, and then let's make sure that if I do something, oh, we'll just say LOL. Oh, I have to put in the additional stuff too. Sending to all, so it didn't get the. Okay, so now we actually need to. Can we optionally have for scanf? I think you can optionally take in values. Let's look at that here. Man, scanf. Actually, let's just, it'd probably be quicker to do it this way. Scanf optional. Is we want to have the situation where we can do tell who message or just type something and have it broadcast. Oh, I guess we can probably do it that way. We can get that initial command. So let's do that. So what we'll do is we'll go ahead and do a, let me just duplicate this line. All right, so I'm only going to get the first. Hold on a second. I want to get everything up to a space. Well, that's what we're going to do up there. And then we're going to get the who. Back here for a second. Read a string. Maybe this is going to actually do what we want it to do. I think a string might stop at the end of at a space naturally. Let's see if that's the case. So I'll just leave the rest the way it is. Yeah, it just got the tell, so it did just read in the one thing, which is good. So then if that is the case, then we want to go ahead and read in the rest into who in the message. And let's do put s who, put s message. Otherwise, we'll do put s command, because that's actually the message we want to send out. Okay. Tell blah blah. So there's our tell. That's who, that's thing, and we're sending the private message, as opposed to LOL, we're sending LOL to all. So we'll take out the extra put things. So we know that guy's working. So we'll just read in that first portion of what the user entered in. If it was equal to tell, then we need to read in the rest of the expected commands. And that's printing out who it is. Who it is. So we can go ahead and do a print f, sending private message. And send s to %s. So this is going to be message and who. Otherwise, we'll say printf, broadcasting %s command. Please enter something. Tell 0 hello. Sending private message hello to 0. Otherwise, we run this and we just say, hi everyone. We're broadcasting. Oh, that is. Oh, it's not a big deal. We can fix that. Let's go ahead and do our \n here. \n here. So if we're broadcasting, we do need to still do our scanf and get everything else. So we'll scanf everything up until the end of the line into message. And then just proving that we got everything. That should be our first space. So we can put a space there. So that should show us the actual message. Then we'll do a string cat to get them together, and that should then give you the starting point you need.
To add a message to print out.
Yep. All right. Hi, everyone. All right, broadcasting. Oh, and it looks like it does read in that space in the first one. Oh, actually, it reads in the space on the second one. So now what we can do is we can go ahead and say char pointer destination is equal to malloc let's see, size of command plus size of message. So that should give us the actual size we need. Then we'll do going to do a string copy. CPY, I think it's that. Destination and then the constant, okay. So we'll string copy into destination command to give us a starting point. But now we know that there's enough extra space after that to give us the rest. So now we can do string cat destination message. And then the working theory here is that we should be able to just broadcast, or say we're broadcasting destination. All right, so after we have our message read in, we should know the size of command, the size of message. We'll add the two of those guys together to get us the total number of bytes we need to glue them together. We'll allocate that into a char pointer called destination. Then we'll copy command into destination, taking up the first portion of destination. Then we'll concatenate onto destination, which has the extra room, message. And then we'll go ahead and print out destination. I think this should do what we wanted to do. Broadcasting, hi everyone. All right. So is that easy enough string manipulation for you, Dover? Kind of appreciate the some of the newfangled languages that have string classes. Well, let's start off that have classes, and then specifically have because I mean think about it from the perspective of all these functions here. We're passing in pointers because these guys aren't returning it. Well, they do return stuff. Most of them return ints, whether things went well. Basically error cases, but you're passing in pointers for them to fill in buckets of memory. So you have to change your mentality and how you think about stuff. All right, so this should be a decent starting point for upgrading your chat server to effectively read in two different types of commands, if you will. Either a message you want to broadcast to everybody, or a specific message where you tell a certain person a message, and that's going to be a private message that you would send to the client you're connected to. Otherwise, if you didn't start your message with tell, it goes ahead and reads in the rest of your line, glues it together, and effectively gives you your full chat message that you want to broadcast. And that's what you're going to broadcast, is this destination string. That make sense? All right. So now let's look at signals. Signals. Oh, there's the peanut butter again.
You close it, didn't you?
No, I left it open. All right, so this guy lives inside of signal.h. So we'll go ahead and bring that into our code. Signal.h. We have our signal handler, which is going to be a function we're going to need. So behavior of signal varies across blah, blah, blah. We have POSIX, so it should be fine. So when we signal something, we signal a number, and there are some built-in ones, as well as the handler. So going to give us, let's open this again. Let's go over here. Bandwidth limit exceeded. You don't see that very often.
That wouldn't be a Concordia thing. That's their website.
Well,
I think it was on their end.
It was on there.
Sure. Would expect it to be.
Okay, so we have a signal handler, and then we also have the ability to do the signal. And these are going to be prototypes we're going to end up throwing into our code. So here's a program to catch a signal, and somebody else is going to have to raise a signal. All right, so this guy has a signal handler and just does a printf. So let's steal some of this in one of our programs. We'll come back to it. In fact, actually, why don't we just go ahead and create a file in ours for our signal catcher. This one. Well, I can do it over here, can I? New file, save, signal catcher.c. All right, there's that stuff. So here's our, this is the function. Instead of prototyping, they just wrote the whole thing. That's fine. So this is a function that receives a signal. If the signal is a signal we're interested in, then he just spits out that, hey, I received the signal, blah, blah, blah. All right, and here's an example of somebody not using curly braces. Remember when I first taught you if statements? I specified that you should always use opening and closing curly braces, because if you saw code that looked like this, let's just assume that second line did something different. You might assume, based on indentation here, that this line is part of what happens when this if statement is true, when it's not. Only the first statement. So the syntax, for those of you who had 470, the syntax of this guy is if Boolean expression statement, where a statement can be a single line or it can be a block statement, which is a collection of statements, which is the curly brace stuff. So punchline is I recommend you always use the opening and closing curly braces, so we'll fix this person's code to be idiot proof. I'm sure half of you will appreciate that.
Also right there.
Who?
Worry about their name.
Oh, in this one. Oh, this is even better. Yeah, this is super awesome. We got a while loop this happens. Yeah, so let's fix all of this. Man, this one's a super. This one tries to really fake you out because it doesn't even indent print underneath it. So actually, this is two interesting things from language evolution. How many of you have ever coded in a language like Python? Any of you ever written Python or seen Python? What can you tell me about Python relative to what I'm likely talking about here? Not just indentation. Indentation matters. So in Python, this printf would not be part of this if statement because it's not indented underneath it. The second you indent it underneath it, now it's part of it. So instead of curly braces in Python, indentation kind of rules, if you will. So that's kind of your fix for if you don't want to use curly braces. Python doesn't support curly braces, but whatever. Yeah, so this one, they didn't even try to trick you. Okay. And then, so this is like horrifically bad programming. So tell me, what is those two, based on what we've learned in here about C, what do those two lines of code do? Well,
it's just like waiting 1 second. I don't know.
One is probably a millisecond, is my guess. It's probably sleep probably takes in milliseconds instead of seconds. But so this one here, what is that guy? It's a Boolean true. So older languages, true and false was 1 was true, non-1 was false. Usually was implemented as 0, but anything other than 1 was considered false. So you could actually do math with Booleans back then. So this says, while true, sleep for a millisecond, over and over and over again. So what does this effectively do? It keeps the this program alive, effectively, but gives enough wiggle room because it's sleeping the thread or the process that's controlling this guy for, let's assume it's a millisecond, maybe it's a second, but we can look it up. But it gives it enough wiggle room that it could actually receive a signal. So actually really kind of bad programming. Okay, so let's forget about that guy down there, but we'll still we'll fix the horribly written code to include curly braces. All right, so what's happening in here? This is checking the return value of signals. This is what we talked about a few minutes ago, that most C and C++ functions return integers, whether or not things went okay. Okay, so this guy is going to raise a signal. What signal? An integer. So sigint is a kind of a common signal. I think you can actually just pass it any integer if you want. And signal. Yeah, the guy takes initially signum, which is just an int. So you can pass it any integer that you want. So if you had a very specific code you wanted to talk between two guys, you could pick your favorite 9-digit integer or something like that. And
Did we have a favorite number here?
yeah, I think probably. I don't know. All right. So in any case, this is going to try to raise the signal. Or as Doomer says, the bat signal, right? Yeah. So this raises the bat signal. It was right from the quiz. It's the only part of it he got right. So this tries to raise the signal. What signal? This constant, which is an integer. I don't know what integer it is. And it sets up the signal handler, this guy up here, as the recipient of that signal. All right, and this asks the question if this guy returns sig error, i.e. something bad happened, do that. All right, so this guy should be self-contained here, where the program starts, all programs begin and end with main. It tries to raise the signal as long as we were able to do the blowhorn thing or the bat signal, whatever you want to think of it. It drops past this, and we go into this busy wait that has enough breathing space in here for this signal handler to be able to trigger. And we should see that we received this signal. Make sense? All right. So let's go ahead and we'll do GCC Signal Catcher. Sashay that out. Is it gonna? It might not be getting enough time in there to actually receive the signal. Let's do there we go. Oh, I'm interrupting it with enough time for it to get the signal. Oh yeah, that's a dead process. There's no coming back from that. All right, so you're gonna allow me to break out? Well, whatever. So now what we'll do is we want to have a signal between two processes. Oh, they actually showed you how to receive it. All right. So we want to have a signal handler. Actually, I think we could probably do it from our child process. So we'll fake it this way. This will be what you need to do for your homework anyways. So we have this signal handler here. And then I'm going to get rid of this busy wait thing. And what we'll go ahead and do let's think about that, because this guy still needs to be around long enough. We need our parent to be able to be waiting on something, so we need some sort of blocking. I guess we can do maybe a scanf. I think that should let us do it. To fake it for now. So let me give myself the new terminal here. All right. So there's our signal handler. We're going to go ahead and if we are the let's have a couple, we'll have one child and the parent. That should be good enough. So we'll say int PID is equal to fork. Fork is in this guy. Oh, we already have it. All right, that guy is equal to fork. If PID is equal to 0, that means we're the child, right? So what do we want the child to do? We want the child to actually go ahead and raise the signal. Else, we must be the parent. And we're going to go ahead and have the, well, let's just do a char pointer input. And then we'll say scanf percent ms input. And then we'll do put s input. But this guy will block on the parent side. So when the child is born, it'll signal this. The parent's going to block, and I'm hoping that we can just sit there and wait, and then this guy will kick in to be able to print out that it received the signal as an example of what you'll need to do. We'll just give it char pointers. Oh, I give it. We have to give it the address. That's right. Address of input. Okay, so it's waiting. Let's assume that guy's definitely sent it now. So we'll say LOL. We have to do the. Maybe the child, maybe we need to have the child get the signal. All right, so we'll have the parent raise the signal. And the child should then not even have to do this. Actually, that should be a pretty good example of what the child would do, is this guy. So let's see if that'll get it kicking. Otherwise, we'll just have to do it inside of our chat server because we already then have the separate guys not busy waiting, but waiting for new incoming connections. Yeah, we'll have to busy wait here to see the example in the. And sleep at a time. This is the only way we can really simulate it in this without us being in our open sockets, which would then be able to receive the signal. I think the child should be able to naturally get it now. If not, this should work on the connected thread. Child not able to write out. All right, well, I guess the only way you're going to be able to see it is in your chat server. Each child process is going to have your signal handler. They're not going to be busy waiting blocking because they're going to be trying to talk over the socket. They should be able to receive the message because they're not sitting there thread locked. All right, so for your homework assignment, bring your private messaging up to date with what we have here in string test. So effectively, this is process chat. So insert this in so you can receive private messages as well as you can receive the broadcast messages, those two different types. So all that code's written. You just have to insert it into your last homework assignment. And then for the signal catching, all you want to be able to do is you want the server to raise a signal whenever a new person connects. And then you want your client threads, your client processes, to just write to their connected client, new user connected. Not who connected or anything, just somebody has connected. Make sense? So they'll just write to their individual person. All right, questions, comments, concerns, bribes?
So we're just relocating the code?
Yeah, I've given you the starting code for this. You'll relocate this into your current project. And then the signal handler thing, you'll have to insert that in the correct place. Have your server raise a signal every single time a new person connects, while it's sitting there listening for a new connection, and then have your client threads, the children, receive the signal, and then when they receive that signal, they would then write out to their the socket that they're connected to that has the actual client, just saying new person connected, just a string proving they received the signal. That should work because we're not doing busy wait in the
So we just meet at your house?
Yep, I'll be over there in 10 minutes.